So hello guys, welcome back to our channel Engineering Educators, engineering in an engineered way. Before start, I would like to request you all like, share and subscribe to our channel and don't forget to press the bell icon. So today I will discuss Bihar PSC Public Service Commission for Assistant Professor post of question paper of 2022. So in this question paper, which is consist of mathematical, engineering, maths as well as the technical portion. So in today's video, I will cover only the technical portions, which is from question number here. It is from 31. So from here, only the technical question paper I will cover today. So first question is, in terms of Poisson's ratio mu, the ratio of Young modulus E to shear modulus G of elastic materials is. So we have to know first the formula, which is E equals to 2G into 1 plus mu, which is again equal to 3K into 1 minus 2 mu. That is the formula. So from that particular formula we can write here E divide G is equals to 2 into 1 plus mu. So ratio of E by G equals to 2 into 1 plus mu, which is option A is the correct answer here. So next question is question number 32. So in this particular question, a metal bar of length 100 millimeter is inserted between two rigid support and its temperature is increased by 10 degree if the coefficient of the thermal expansion is 12 into 10 to the minus 6 then per degree Celsius, and the Young modulus is 2 into 10 to the 5 megapascal, then the stress in the bar is. So suppose this is the bar, so it is fixed in the both side. So from that bar, which is here everything, here value temperature increase, that is dt is given 10 degree, and alpha, value of alpha thermal expansion is 12 into 10 to the minus 6, and Young modulus value of E is given here 2 into 10 to the 5 megapascal. So we have to know the formula first. So thermal stress, we know thermal stress sigma T, which is equals to alpha into T into A. So just put the value of alpha, T and E, then you will get the answer, which is 40. After calculating all those value, you will get the answer is 24 megapascal will be the correct answer. So let's move on to next question, which is question number 33. For a simply supported beam on two end supports, the bending moment is maximum. So for that particular question, we have to know another one formula, which is Fxx. F is here shear force at xx cross section is equals to dm. Here m is the derivative of moment, dm by dx at xx cross section. That is the formula. So from that formula we can say for m maximum moment, dm by dx must be equals to 0. So then only you can say m is maximum or minimum. You can find out the value of m, whether it is maximum or minimum, only and only if dm by dx is 0. So from here we can say Fx equals to also is equals to 0. So at shear force equals to 0, at 0 shear force position we will get the maximum moment. So that is the answer here. So here option, so it's question 33, option C, where there is no shear force. Sorry, here option C, where there is no shear force. It's for for bending moment maximum, it's where there is no shear force. Option C will be the correct answer. So let's move on to next question, which is 34. So for that particular question, let's see what is the question. The deformation of a bar under its own weight or self weight as compared to when it is subjected to direct axial load equal to the same self weight or own weight will be. So we have to calculate the ratio. So we have to calculate the ratio for question 34, that is deformation for self weight SL, suppose it is SL, to deformation to axial load AL. So we know deformation formula for self weight is, if the load is self load is P, then PL by 2 A is cross section area into Young modulus 2AE, or for axial load it is PL by AE. So answer will be half. So ratio will be half, which is option C is the correct answer here for question number 34. Next, move on to question 35. If the value of Poisson's ratio is 0, then it means that, so what is Poisson's ratio? So Poisson's ratio, we know mu equals to minus epsilon y by epsilon x. So Poisson's ratio is 0 means value of fx y, epsilon y is also 0. So that means material is not deforming at x direction. So material, you can say material is a rigid material. After application of load, material is not expanding or deforming. Okay, so that means if epsilon y is 0, so from here we can say material is rigid material. So which is for question 35, which is answer A, material is rigid, will be the correct answer. Let's move on to question 36. A thin cylinder of inner radius 500 mm and thickness 10 mm is subjected to an internal pressure of 5 megapascal. The average circumference or hoop stress is in megapascal. So first of all, we have to know the formula of hoop stress, which is sigma h equals to P d by 2t, or from here we can write d by 2 is equals to r, so we can write here p r divide t. So just put the value of p is here 5, r is 500 and t is 10. So the answer will be 250. Answer will be 250 megapascal. So which is option B, 250 megapascal is the correct answer here. So let's move on to next question, which is 37. The minimum number of link in a single degree of freedom planar mechanism with both higher and lower kinetic pair is. So if all the links are lower pair, for that particular case we know minimum number of link required is 4. For all pair is lower pair. So one lower pair, two lower pair equals to one higher pair. We know one higher pair is equals to two lower pair. So from that relation we can say minimum number of link here for that particular mechanism for both higher and lower pair is required is minimum is 3. So option B will be the correct answer here. Next, move on to question 38. When the cylinder is located in a V block, then the number of degree of freedom which are arrested is, see here the term arrested, not degree of freedom but the arrested one. Okay, so it is very clever question. So let's see the answer here. So suppose this is one V-type block. This is one V-type block. Here one cylinder at that block. You can imagine it's here. So the cylinder can move only two direction. One, that is one oscillating direction in this two direction, and the rotary motion. So here degree of freedom is 2, not the arrested motion. So for arrested motion we know what we have to do. It's 6 minus degree of freedom, that is 2, which is equals to 4. Here answer will be 4, not 2, but 4 will be the correct answer here. Okay, so let's move on to next question. The Coriolis component of acceleration is present in. Coriolis component means it is present in slider crank mechanism. So let's see what is Coriolis component. So suppose this is a link, it's fixed here. One slider is located on that particular link, and that link is moving in that direction, rotating in that direction. If link is rotating in that direction, then slider will slide in at that position, at that particular position. Slider will slide at the upper position. So that effect is known as the Coriolis effect. That is the actually Coriolis effect or Coriolis component. Here from that particular effect we can calculate the Coriolis component acceleration. Okay, so that is actually the thing. Here for slider crank mechanism it is present. So next is question number 40. So in a kinetic chain, a quaternary joint means 4. Quaternary means 4. 4 joint is equivalent to 3 binary joint, which is option C is the correct answer here for question 40. So let's move on to question number 41. A point on a link connecting double slider crank change will trace an A or N. Okay, if double slider crank means the electrical turmoils, the examples of double slider crank is electrical turmoils, Oldham coupling, stock yacht, like this type of mechanism. Here you can remember those type of mechanism. Here one sliding bar is here, 2 sliding bar is here, double sliding. It is double slider crank mechanism, and one connecting rod is here, connecting link is here. So we have to answer that path of that particular link is elliptical type, which is option D is the correct answer here. So next question is 42. Here a turbine operates under steady flow condition, receiving steam at the following state. So those are the inlet state, where pressure P1 equals to 1.2 megapascal, temperature T1 is 188 degrees Celsius, enthalpy H1 is 2785 kg per kilojoule per kg, velocity V1 is equals to 33.3 meter per second, and elevation which is H1 equals to which is Z1 equals to 3 meter. And for exit, here you can see for exit steam leaves at turbine. Those are all exit conditions. Pressure 20 kilopascal, enthalpy 2512 kilojoule per kg, velocity 100 meter per second, and elevation here Z2 is equals to 0 here. So here heat loss to the surroundings at a rate of 0.29 kilojoule per second. If the rate of steam flow through the turbine is 0.42 kg per second, then what is the power output of the turbine in kilowatt? So it is a very easy question. So let's see how to solve it. So we have to apply the steady flow condition. So for steady flow condition, we know the conservation of energy is equals to, which is at inlet H1, at inlet, which is H1, H is here enthalpy, H1 plus C1 square by 2, here C is the velocity at inlet, plus G Z1 is elevation at inlet, plus Q dot is heat transfer rate, is equals to H2, which is at outlet, enthalpy, plus C2 square divide 2, which is velocity at outlet, plus G Z2. Z2 is here elevation at outlet, plus W CV control volume, work done. W is here work done. Okay, just put all the inlet and outlet value here, you will get the answer. You will get one step towards answer. So just put H1, value of H1 is 2785 plus C1 square by 2, which is 33.3 square divide 2, but the here it is in joule per kg. It gives the unit in joule per kg, but we require unit in kilojoule per kg, so that we have to multiply here 10 to the power minus 3 plus 9.81, which is value of G, into elevation at inlet is 3. It is also in joule per kg, but we have to make it in kilojoule per kg, so that's why 10 to the power minus 3. So those are the inlet values, plus Q dot. Q dot we know is 0.29. Okay, then which is equals to the outlet values. Outlet at outlet output, it's 2512 is the enthalpy, plus the C2 square by 2, which is 100 square by 2 into 10 to the power minus 3, plus G into 9.81 into Z, G into Z. Here Z is 0. Z is 0. So whole term will become 0, into W. W we don't know. W we have to calculate. So WCB, from here we will find, after calculating whole equation, we will get the value of W is WCV at control volume is equals to 268.8738, that much kilojoule per kg. We have to make it in power, in kilowatt. So power P is equals to m dot. Value of m dot we know. M dot mean mass flow rate. Mass flow rate is given, which is 0.42 according to the question, into W. Just put those values. 0.42 into W is 268.87. You will get the answer, which is 112.9270. That much of kilowatt. That is the answer. So which is option C. So question 42, answer is option C, 112. That is the answer. So let's move on to next question. It's 43. So 43, the specific heat of an ideal gas depends upon, it's always depend upon molecular weight and the structure of the atoms. Molecular weights and structure of the atoms. That is the correct answer. So question 44. 44, 4 and 2 cycle coupled in a series. Topping cycle has an efficiency of 30% and the bottoming cycle has an efficiency of 20%. Then overall combined cycle efficiency is. So let's see the elaborative way, then I will tell you the shortcut. So first let's see the elaborative way. So let's see, that is the engine 1. Here the output, W work output, then that is the lower reservoir, and that is engine 2, and that is output, that is lower reservoir for engine 2, that is work done W2. So if it is Q1 and it is Q2, heat rejecting is Q2, heat supplied at engine 1 is Q1, heat rejecting at Q2 from engine 1, and from engine 1 to engine 2, from engine 2 heat supplied is also Q2 here, that heat will supply to engine 2, then engine 2 to engine lower reservoir, it's Q3. So from that particular equation we can say efficiency for engine 1 we know is 30%, that is 0.3, which we can, efficiency formula we know is 1 minus, for engine 1 minus Q2 by Q1, and for engine 2 efficiency is 20%, 0.2, which is equals to 1 minus Q3 divide Q2. So those, from those two equation 1 and equation 2, from those two equation we'll get the value of Q3 by Q1. So after solving those two equations we will get the value of Q3 divide Q2 is equals to 0.56. So again we can write 1 minus Q3 by Q2 is equals to, so just 1 minus 0.56, which is equals to 0.44. So that is the overall efficiency. So efficiency overall is 44%. We will get the value from here. So 44%, or option B is the correct answer here. You can see option B, 44% is the correct answer. So now I will tell the shortcut formula. So for overall efficiency, shortcut formula is efficiency 1 plus efficiency 2 minus efficiency 1 into efficiency 2. That is the shortcut formula. Just put all the value here, 0.3, here 0.2, here 0.3 into 0.2. Just you will find the answer is 44%. So let's move on to next question. Is question number 45 here. Question 45. At triple point of a pure substance, the number of degree of freedom is so to solve that particular question we have to know Gibbs phase rule. So according to Gibbs phase rule we know P plus F is equals to C plus 2, where P is number of phases, F is degree of freedom, C is number of component, and 2. So here we have to calculate F, value of F or degree of freedom. So F equals to here C, number of component is here 1. So number of component is here 1 plus 2. If P comes at that side, so it is minus P at triple point, means phase is 3, triple point. So ultimate answer will be 3 minus 3, which is 0. So option A for question 45 will be the correct answer. So let's move on to next question, which is question 46. An economizer. An economizer is a steam generator performs the function of, option A is the correct answer for 46. Sorry, not option A, it's option B. Preheating the feed water is the correct answer here. So next is 47. Which of the following is a pressure compounded turbine? So here option C, Rattau turbine, is the correct answer for question 47. So let's move on to next question, which is air standard cycle consists of. So here air standard diesel cycle has consist of. So let's see the diesel cycle at PV diagram, then you will automatically find out the answer. So for PV diagram, diesel cycle is here at constant pressure and it is like this way. Here it addition and here it's heat rejection. Here work done, that is the work done, and that is the sorry, that is sorry. Let's let's draw it again. Here PV diagram, P and V. Here at constant pressure, heat addition, it is compression, expansion and heat rejection at constant volume. So constant volume, here is the compression, that is the constant pressure, heat addition, that is the expansion, and constant volume, heat rejection. So here two are the adiabatic process, and one constant pressure process and one constant volume process. That is the correct answer. So here option C, one constant pressure, one constant volume and two adiabatic is the correct answer for diesel cycle. So let's move on to next question, which is question 49. So knocking tendency in a spark ignition or SI engine, is SI engine reduces with increasing engine speed, which is option D for question 49 is the correct answer. So next question, which is question 50. A heat pump works on a reverse Carnot cycle. The temperature in the condenser coil is 27 degrees Celsius, and that is the evaporator coil is minus 23 degrees Celsius. For the work input of 1 kilowatt, how much is the heat pump? So first of all, we have to know the cycle. So higher temperature is here 27 degrees Celsius, that is the heat pump, and here work input is 1 kilowatt, and that is Q higher, that is Q lower, and rejecting at temperature of minus 23 degree, lower reservoir at minus 23 degrees Celsius. So from here we can write the COP. So COP we can calculate is T higher divide T higher minus T lower. That is the formula we know. So T higher is 27 degrees Celsius. We have to convert it into Kelvin, so which is 300 Kelvin, and T lower is 23 degrees Celsius. We have to convert it also in Kelvin, which is 250 Kelvin. So after calculating all those value, we will get COP value is 6. So COP is 6. So from here we can write again COP or 6, which is equals to Q higher divide Q higher, that is for heat pump, Q higher divide work input. So Q higher we know, Q higher we have to calculate Q higher, and work input we know is 1. 1 kilowatt. So 6 into 1 is 6. So 6 kilowatt is the correct answer, which is option C. Option C is the correct answer for question 50. Let's move on to next question, which is 51. The coefficient of performance COP of a refrigerator working as a heat pump is given by. It's a very repeating question for every exam, every government exam you will find that particular question. It's just a formula. Correct answer is COP of heat pump is equals to COP of refrigerator plus COP of refrigerator plus 1. So here 1 must be missing here. So COP of refrigerator plus 1, which is option A. Option A for 51. Let's move on to next question, which is question 52. So an ideal refrigerator is operating between a condenser temperature of 37 degree and evaporator temperature at -3 degree Celsius. If the machine is functioning as a heat pump, then its coefficient of performance will be. So it's also a very easy question. So first we have to know the higher temperature. Higher reservoir temperature is 37 degree Celsius. That is refrigerator is here for 52. Condenser temperature evaporator. Refrigerator is operating here. Refrigerator. So here the heat input, and lower reservoir temperature is -3 degree Celsius. So from here we can find out value of COP is equals to so here the COP for refrigerator, COP for refrigerator. So it is for -3 degree means 270 degree means T lower is 270 Kelvin, divide T higher minus T lower, which is 40. T higher minus T lower, which is 40. So ultimately it's 270 divide 40, but we have to calculate the heat pump. So we have to calculate the heat pump. So from that we can write COP of heat pump. COP of heat pump is equals to 1 plus COP of refrigerator. So that means 1 plus here 0 will cancel out. So 27 by 4, that is 1 plus 27 divide 4, which is 31 divide 4. So ultimately it will 7.75. Answer will be 7.75. Option D is the correct answer. So let's move on to next question 53. For a given heat flow for the same thickness, the temperature drop across the material will be maximum for. So for that particular question we have to know the Fourier law of heat transfer, which is Q dot. Q dot means rate of heat transfer is equals to del T. Del T means difference in temperature, divide B by K into A. Here B is the thickness and K is the K is the constant coefficient for conduction, and A is the area. So from that particular formula we can write del T is proportional to drop in temperature, which is proportional to 1 by K. So as the value of K will decrease, the temperature difference in temperature or drop in temperature will increase. So from that formula we can say, so minimum conductive material will be here correct answer. So which is glass wool. Glass wool has the minimum conductivity among those material. Copper has the highest conductivity and glass wool here is the minimum conductivity. So here option C is the correct answer for question 53. So next is question 54. Let's see. A stainless steel tube of Ks means its conductivity is given 19 watt per meter Kelvin of 2 centimeter. ID means inner diameter, and 5 centimeter of OD or outer diameter is insulated with 3 centimeter thick asbestos. Okay, then K is the asbestos conductivity, which is 0.2 watt per meter Kelvin. If the temperature difference between the innermost and outermost surface is, that means DT value is given is 600 degree Celsius, then heat transfer rate per unit length will be. So it's a very easy question. It's just you have to know the formula to solve that particular question. So for it's a problem of cylindrical problem. So here if it is the stainless steel tube, that one the stainless steel tube, here the inner diameter, you have to know the inner radius, then that is the outer radius, then thickness, above that is thickness, insulator, asbestos insulator is here, so you have to know the radius of that particular insulator. So just put all the value in the formula. So formula for Q by L is equals to del T divide ln if it is R1, if it is R1 it is R2 and it is R3. So then ln divide R2 by R1, R2 by R1 divide, so make it clear here. So formula is Q by L is equals to del T divide ln R1 divide R2 divide 2 pi K1. K1 is here the stainless steel conductivity of stainless steel plus ln R3 by R2 divide 2 pi K2. Here just simply put all the value. R1 value you know, D1 value you know, just D1 divide 2 is R1. Similarly R2, R3, R2, R3, all the value, and Q1 that is for stainless steel and that is for asbestos, and DT we know 600. Just put all the value, you will get the answer. Answer will be here option C, 944.72 watt per meter. It's a very easy question. So I think you have enjoyed the video. So I will cover rest of the technical question in part 2 of that particular video, of my next video. So thanks for today. Have a good day. So thank you.